Attention span and working memory have stood to the forefront of why students start school strong or start school weak. Okay, one more time, kindergarten people. Students with weak working memory and poor attention span start school weak. Later on, we're going to find out the students who come in kindergarten and do not have a twice performance, in other words, 2 years of learning, two age levels of growth in one academic year, they do not, we'll find them in 5th grade, they'll still be below. That is actually horrible. It's 70% of the students who struggled in kindergarten will remain the same 70% of the students who are the worst performers in 5th grade. So in other words, there's no magic that occurs in between. So we are the magic. So here's one of them is chunking. So I'm going to take where we went with this, and then I'm going to show you one way that I came up with it, and then I need you to start recording ways that you're going to think of a math topic. I'm going to show 2 up here, and only 2. I think I do a second grade and a 5th grade. And the 2nd grade we don't even do anymore. I chose the Common Core one, now that North Carolina one. I want you to create that task analysis based on this. So let me model first. All right, I've got lots of ideas. You can always go back through my steps. They're very important. There are 8, so I know if I present them all to you right now, this is me talking to myself. So I'd much rather show you what we're doing and then come back. So we talked about how to read an analog clock, because I'm the only one who does, right? Anybody else have a watch? Yeah, no, it's digital. Oh, there we go, look, okay, there's 5 of us. We're a little teacher pack right here. All right, so I'm the only one in the world who still cares about analog clocks. There's 5 of us, yay. So I have here, identify the hour and minute hand, right? The differences between them. The second step, they have to be able to count by 5s, right? And by the way, that's not skip counting, right? Those are just multiples. If anybody ever says, look, we're doing skip counting, and they go 10, 20, 30, that's okay. Say yes, that's it. But make sure that they understand later on, those are actually just multiples. Skip counting is 3, 8, 13, 18, right? Start with some weird number to screw it all up. Multiples is actually what you want to start and focus on. All right, determine the hour according to the placement of the hour hand. That short sucker is somewhere near 2, the time is somewhere around 2. Then determine the minute according to the number at which the minute hand is pointing. And that's where this is at, the 10. And here comes our 5, 10, 15, 20, 25, right up to 50. So here's how I'm going to group them. I know my students are going to struggle, so I'm going to group them. I'm going to group these 2. Oh, me and Microsoft PowerPoint are having a good time. I'm going to group 1 and 2, and then I'm going to group, anytime, buddy. And I'm going to group 3 and 4. The first 2, the teacher team that did this, they had data that they already had students that learned how to do this. So I said, I'm not going to pretend they do until you pre-test them. Which meant that her lesson had to do with first pre-testing these 2 steps. Do they know the multiples, and do they know the difference between an hour and minute hand? Then they had one block, one chunk that they're going to teach. And that's determining the hour hand placement, and then determining the minute hand placement. That's all they did. That was the lesson. So here's the next one, computing volume of a solid. We got 6 steps here. Understanding that volume is in cubes. So that's important. Recognizing the 3-dimensional aspects of the figure, base times height. Check that the figure is measured in the same units. Calculate the base, multiply the base and the height, represent the answer in cubes. Everybody kind of agree who teaches that? It's pretty generic. Then we went back through and we said which ones are which. We found which ones should be already understood before this 5th grade lesson. All right, if you do a curriculum mapping, you find out this has already been taught. Whether they mastered it is a different story. Mastery might have been 3 weeks ago. Let's find out if mastery still exists today. So understand that volumes and cubes and recognizing 3-dimensional aspects, a base and a height. Then here's my lesson. So that's listed out. I'm now going to teach this. Check that the figure is on the same units. So I actually have a lesson where I give them a figure and they have to point out which ones are cubic centimeters, which ones, oh gosh, wait, this says cubic inches. So guess what we have to do? Now we have to spend time recalculating. So that conversion takes place. The next one, calculate the base, right, just by itself. Once we master that, then we get on to multiply base and height and represent it in cubic units. So far, no problems, right? You know what I'm going to do for you guys now, right? What am I going to ask? You got it. I need you to find a standard to do that. Oh, wait, all my fancy things. Here we go. I need you to think of a standard that you're coming up. If it's coming up on Monday, what standard are you teaching? Missed out a little backwards chaining discussion here, but I actually without that term. What's the final outcome that you're looking for? When you're looking at a standard, look at the verb, computing volume. If it's a computation standard, I need to have a computation end to my discussion down here. If it's recognized, that means they're identifying something over there, right? Make sense? So, go through, if you have a partner here, this is a good time to team up with a partner. If you, oh my gosh, I don't even know where to begin, I brought a textbook with me. All right? 5 minutes, on your mark, get set.
Like I did chunk it just naturally in my lesson. Like you're so afraid, just like regular shapes. So the next day we added like hexagon, pentagon, and stuff like that. And then I gave the actual 2 days to practice that. Then I added like regular polygons, irregular polygons, you know what I mean? Stuff like that. And building it up to the final one.
$5 for a teacher.
That way it's
We're Jesus report. This is also my twin, so we don't
I mean, I guess I just naturally chose it, you know what I mean, just because of the type of classroom I have, but... Yeah. And like you said, like SPC teachers is different from regular ed teachers. You know, they might not have that flexibility to really chunk it. Like you said, we understand it. Just teach the whole lesson, they're not going to get it.
But I get to try how well okay, so I'm doing the same thing this time, right?
Yeah.
So do I have to this?
All right, who feels really confident with what you're doing?
Together and this side together, yeah,
I usually have my students like underline pushing and then I said they automatically see its numbers and everyone went ahead about you.
Well, no, literally transfers into math too. Oh my God, I don't even, you can, I was
no, oh yeah, 2 and 3. Yeah. Like that on
They get frustrated so that they don't all learn this and stuff like that.
I just went there and I think that sometimes
For just a second, and let you get right back to it. I want to describe how I'm doing this approach. Now, for me, this is 2-digit subtraction, and I put it in parentheses with regrouping. So I'm going to teach you, my hope is that I'm going to show you task analysis, but I want to teach you another way to look at this. And this is through an intervention series that we have for students with learning disabilities. So take a look at this one. I'm going to give you an example first, and then I'm going to show you where we're going with it. 82 minus 17. And I actually have a kid doing this too on video, but we're working on it. We know the sound isn't right yet. So we'll do the kid video later on. So I actually the first thing I want to do is the student has to put this out as expanded notation. So I want them to say this is 80 plus 2. And I want them to look at this as, yes, you got it, negative 10 minus 7. Now, something we haven't really talked about much is you do expanded notation because you want place value to come in. So this is not 80 and that's not 10. This is 8 tens, 2 ones. This is negative 1 10, negative 7 ones. All right, the next part too is I want them to calculate by the tens. Focus on the tens first. Show them multiple colors. Bad professor. Okay, so I'm going to go over here. What is 8 tens minus 1 10? What's 1 10 less than 8 tens? 7 tens. All right, so we do the tens. The next one we do? Ones. What is 2 minus 7? Now, we haven't done that here yet, and we're going to play a little bit later on. But 2 minus 7, if you're thinking I have students who won't be able to do this, I'm going to tell you how much easier it is to do this than it is to have a counting down subtraction, where I'm going to have some poor kid doing some cheating method of counting on his fingers. So we actually do this, I have 2 minus 7, and we actually start with number lines, which is, I forget when we're doing number lines here, but these are opposite directions on a number line. What's 1 minus 1? 1 minus 1 is 0. Here we go. So 1 minus 1 is 0. 2 minus 7 is what? Negative 5. So I end up letting the student work through this one, and they go through and they say, so what is 2 minus 7? Negative 5. I then go through, what's the total? What's 70 minus 5? 65. So for this, in my strategies, I've got 4 major steps that I need my students to understand in order to compute two-digit numbers with subtraction, or with regrouping. I knew I was going to say that wrong somewhere along the way. But I'm subtracting two-digit numbers with regrouping. You knew it was going to come out. All right. So I start with the problem presented. I then go to expanded notation. I focus on doing the tens. Then I focus on doing the ones. And then I total my answer. Make sense?
Yeah.
Okay. Anybody teach algebra? We have covered, right? Algebra 2. If you go through algebra 2 and you're working through sympathetic division, guess how you end up going through it all? That's where expanded notation ends up going. That's where the computation ends up. The negatives have just the same power. And by the way, so right now what we found is students with LD, you know what they end up doing? They spend so much time trying to cross the clean. Look at what they do. All right, I know I drew my marker. Okay, I'm going to go wrong color. All right, so you know what students do with 72 minus 17? You can't take 7 from 2. That's the first thing they start out with, which is wrong math, bad math. So they go, you can't take 7 from 2. So I'll borrow from, not the 8 tens, I'll borrow from the 8. That makes this 7, and that makes that a 1. Because 7 and 1 make 8. Guys, it's not 8. It's 80, it's 8 tens. But that's what they say. They then say 12 minus 7, that's 5. 7 minus 1 is 6. 6 and 5 next to each other is 65. How many math errors were just made? Oh, procedurally, it's awesome. Place value was made 3 times wrong. The subtraction rule was wrong. And 6 and 5 next to each other does not make 65. You got, it could make 11. If I multiply them, someday they're going to put a parentheses in between them and I've got groups of them. So all these little things, in order to get to that quick outcome, we skip through the right steps. And guess what ends up doing it the best? Well, the teacher. But you know, you and I, how were we taught? We were taught the person who can memorize this or regurgitate this is the smartest in the room. And then we loved instruction, we loved school. So what do? We want to go back and help others. And how do we teach it? Based on the same way that we were taught. Well, how were we taught? Based on a memory piece that actually was never conceptually grounded. And now I've got a group of kids who can't follow my concepts. And I'm like, what's wrong with you? I did it. I don't think I'm that smart, and I could do it. Right? And, well, it's because of all the errors that are embedded in our language.
But we do it that way, but we embed it with our place value blocks. We bring those tangible, visual manipulatives in to help them understand, and we do verbally say that
The tens
it's 80
and the ones.
and I mean,
So-
so we're saying we're doing that wrong?
No, so what we need to do, I love it, you're so defensive, don't
I
go
am.
get there yet. Don't go there yet, hold on, hold tight. So why then are we talking about this negatives mixed in between? What's the purpose of mixing the negatives early?
So that when they get to do negatives, they're already exposed.
It's already part of the curriculum. They've already had the exposure. If you know how learning goes, exposure first, application at the end.
Yeah.
And so when they enter sixth grade, it's the, oh, by the way, this is all application go, and they have no exposure to it. So how do we do this? How do we combine this? I'm already doing expanded notation. What's my next step? So, okay, you know what we're doing here? We're doing a curriculum mapping. At the same time, we're doing task analysis. Give me some ideas. Slow down, I can't hear everybody. How do I take this expanded notation piece? When do I start introducing a negative piece? And maybe with whom? Who ends up messing this up the most? The elder kid, right? You're putting out graph paper, you're turning paper sideways, you're trying to keep them down in certain perfect lines, because you know that they're going to mess it all up. Then you go into the point, okay, listen, I need you to do expanded notation out. And I'm just going to add the steps to it. So if I do expanded notation out, then I say, first, do not say you can't take 7 from 2. That would be the next step. So you don't take, you say, you have not yet learned how to take 7 from 2.
Yeah, I say that all the time.
So then we get to go through, I love, boy, we'll be arm wrestling later, that's okay. But what you then do is, right, you're going to say, I have 8 10s here, so I have one of my 10s. I'm going to make it here just to make the computation easy. By the way, I'm going to throw it out and just be muddy with this. You can take 2 10s and move them over here. You can take 4 10s and move them over here. Expanded notation works in that manner, right? So that's why it wasn't called expanded notation beginning. They actually just called it decomposition. So all we're going to do is decompose this 8 10s and move them. Why am I going negatives for students with LD rather than making them do that regrouping and borrowing first? Fewer steps. And what? So by reducing the number of steps, the longitudinal piece comes out. So we're finding out our second graders with LD who are taught early up front to do this reduction of steps and learn integers. Their sixth grade introduction is, oh my gosh, these kids already know it. What happens to kids who already know something? How do kids do upper level math? How do they act in class? How's their behavior? Is it awesome? Why? Why aren't our kids who struggle in math, why don't they sit in math class politely? Because they don't get it. And what happens when they don't get it? They're going to find something else to do. Anybody here in college who ever walk into the wrong classroom, particularly your freshman year, right? What ends up happening when you walk in?
I didn't see the
I have no idea what's happening. Do I look the part? I think I'm in the wrong room. What class is this? Oh my gosh, right? Or it's what class is this? Oh, that's why I don't understand, right? And you're like running out to the registrar, really, is what you're doing. I need to drop. The reason why that happens then is because you know you don't have the exposure to keep up with the instructor's point. Guess what happens in high school, in middle school, upper level elementary? When they walk in with a lack of information, they said, I can't do it. You can break it down to the 9th degree, so it's so easy on them, and they're already have tuned you out. Because motivation, by the way, is the #1 issue between middle school and high school teachers and Algebra 1, not special ed. Gen Ed, motivation is the #1 issue with high school and middle school Algebra 1 teachers. So where I'm going is, if we can beat them to the word, and I can give them little exposure up front, guess what ends up happening? Later on they're told what? In 6th grade, what's going to happen to him when he starts to be negatives? You are so smart, because we don't know you have been taught. They're going to say you are so smart. So what ends up happening there? Now I've got a kid who sits up front, he sits a little more upright, and he's trying to take notes. He's now trying more. So I'm going to introduce you to 2 kids who I work with. I'm going to give you some pseudonyms with them. One of mine is named Josh. Josh came to me in 4th grade. He's actually at a university I was teaching at. Vice president had a kid who's struggling with LD. It was his own child who said, I need you to tutor my boy Josh. And when the vice president comes to your university, your answer is, of course! 7, 8 hours a day, let's get it going. Right now, every other Wednesday, we'll do an hour or 2 hours with him. Josh hated math, couldn't stand math in 4th grade. He despised all math. So when he came to me, you know what he did? He brings homework to me. This is what we're doing in class. So I knew I could not do 4th grade homework with him because he'd already given up. So what did I do? I pulled out a 5th grade book, scaffolding, I pulled out a 5th grade book, and I know where this lesson is going next year. And I said, come on, I hear you're really smart. Let's try 5th grade. I can't do that, I can't even do this. Let's try. Because there's so much overlap in the standards, as you see. I taught him a 5th grade lesson, and he could do it at the end of the lesson. I broke it down in small chunks. I eliminated some of the extraneous pieces that I know will fall apart later on in his career. And guess what? He starts being able to do it. Every time he came in, he knew not to bring me homework, right? Resource rooms, right? That are homework catchers instead. I would not do that. So I would, right? I spend enough time in my resource room that not doing homework. So I would say, listen, I'm not going to do that with you. That is homework. We are not home. So you're going to do this with me. And so I set up the next lesson, and guess what ends up happening? He starts getting a little better grades. Not great, little better grades. But what did I really set him up for? So in 4th grade, he did okay. What happened next year? He did awesome in 5th grade. He boosted his confidence. He said, oh my gosh, my teacher's so much better. Right? Right? You know where I'm going? Sure. Listen, this is not my job. The best special ed teacher's out of work. Right? So I don't want to be praised for this. I just want to say, well, good. I'm glad you finally got a good teacher. I knew the last teacher too, and she was great. I never said that part. I just, okay. But now he's got it. Over time, all this tutoring will always be advanced ahead. Josh just finished his 3rd year at MIT studying pre-engineering. LD hated math. Now I'll give you another one. Eric comes to me, you know this about special ed, no matter where you live, there's a neighbor with a disability, right? And they come and knock. And so there I am, I'm down in Florida, here comes Eric. The family owned an air conditioning company. I lived in Florida, and the family owned an air conditioning repair company. I want to be friends. Okay? And trust me, Eric's family, we still keep in touch, all right? So Eric's working with me, he comes to me in 6th grade, hates it, hates math. So, I mean, to the point where he wouldn't even attempt the problems with me. My mom sent me over. That was what he said every time. And I went, okay. So I pulled out a simple set of materials, not expensive stuff, the cheap stuff. Stuff like addition, subtraction, reverse cardstock. When I'm counting, popsicle sticks. Things that we can find in our home. Cups for grouping. And we start doing algebraic equations. Not algebra, hold on, algebraic equations. And the answer, we'll do at the end here today, everything up in the cup. He goes, so the answer's 2? Yeah. That's it? Yeah. Well, can we do another one? I don't know. Do you really want to? So we worked with him a couple times over, and I say we, my wife was there bringing the food because someone had to be smiley. Geeky math guy, he didn't want to spend time with me. So during the time, I just probably worked with, oh gosh, Eric, I didn't use this pseudonym. I'm guessing 3 years I worked with him on the side. Eric graduated 3 years ago from the University of South Florida with an electrical engineering degree. His master's degree. I'm not telling you that's the answer. What I'm telling you is, if we spend so much time with special ed kids trying to meet the day-to-day, there's a reason why they're here. It takes 2 years in school for 1 grade level growth for kids in math, for special ed. But one more time, 2 years in school, 1 grade level growth. Literacy is worse. The average is 3 years in school for 1 grade level growth. So if I'm trying to keep up with him on a day-to-day basis, I will fall behind. Therefore, everything I do is in much further out prior planning. And thank goodness for the math degree, because I could know where things would fall apart and I knew which ones would never come back. So that's where I went, oh shoot, if I'm going to get into Algebra 2, the new research, by the way, Algebra 1 is no longer a gateway. Algebra 2 is our gateway. And we'll explain what happened. Those of you who've been in the upper level grades for a long time, you know what happened. It's that watered down effect. To make every kid needs to pass algebra, and so we watered down what algebra meant. So now the real research is Algebra 2, just to get to community college. One more time, Algebra 2 is actually the best predictor we have for technical school degrees. So everything I do right now, talk about backwards chaining, I plan Algebra 2 lessons and where they go. Every time I write a book, we plan Algebra 2. So I know I'm boring you. Council for Exceptional Children knows about that research, so when they pulled me aside, they said, Brad, could you get some of the national math panel guys together and write a book of what we need to do to prep those kids to get through Algebra 2? So we put it, it's called Bridging the Arithmetic to Algebra Gap. So in this, and it's CEC, for CEC members, that means good cheap stuff. Because I get like 30 cents per book, so it's, I know someone else I hope is getting that money. But when I wrote this, everything was talking about how do we set up this lesson so the next ones will be easier. So I hope that makes sense. I'm great with having arguments and discussion, and I want that. I know this, I'm not anti at all, I'm pro, because when you say I'm defending, it means that you have the knowledge, you know where you're going with it. That's a great conversation. My real concern is someone in here right now is going, I have no clue what he's talking about. That's my worry. So let's play another one. We're back on you. What are you doing in your task analysis to help set up that long-term piece? Anybody feel really confident with it? Okay, we're gonna come back to it. Do not throw away where you started, because the next lesson actually piggybacks off of it. So we started this discussion with, we started this discussion with a math standard that I want to break down into small components, right? Guess what our next steps are going to be? How are we going to break those down into minor, itsy-bitsy pieces? So let's talk about those tricks. First thing is when we write these out, we got to get rid of the tricks. So if you started writing this and say, well, why do you do it? I don't know, and you're trying to do out the math, which by the way is always the best way to plan how to teach a lesson. Do a couple problems and say what's common. But get rid of the tricks. How do we convert that to what used to be called, we no longer call it the standard as an improper fraction, right? But how do we convert this number into an improper fraction? What are the steps? So first, what's the answer? 22 fifths, or over 5, right? So how do I get that?
5 times 4 plus 2.
So we go, right? 5 times 4, then we add 2, and then we just slide the 5 over, right? It just goes over there. You see the tricks that we're developing. Anybody do this in their class? You just draw arrows? Yeah, I did the same thing, and when Pearson asked me to write a book on fractions, Paul Rickard and I tore into this and went, why? Anybody know the answer? I know people know this better than I do. It took us a while.
Why is it, you're asking, why is it 22 or 5?
Why am I multiplying then adding?
Because you have 4 whole pieces that are broken into 5 pieces each, and then you have one that's broken into 5, but it only has 2 of them.
Oh, I love it. So if I've lost my place, it's going to flash back and forth. Bill Gates and I are not on the same page. Hold on. Because when I'm going through 4 and 2 fifths, 4, what do we do mathematically when we hear and? If there's 2 things in math, decimals or addition, right? So I'll use this one. A decimal works just the same, by the way, because and 2 fifths would work. 2 fifths. You said I have 4 whole pieces. Why did I multiply 4 times 5 first? Right? Because I wanted like denominators. Why did I add? Because now that I have fifths, I'm only talking about fifths. What's 20 plus 2? 22. Why did the 5 randomly slide over? Because it's the new base of the number. But think about all the tricks that you and I learned. And then I've got kids who I teach the tricks to them, and what do they say? I don't get it. What's happening? I don't understand. Or they're multiplying the wrong numbers, and they're adding the wrong numbers, and then we're trying, no, you had this one. And you're trying to find yourself so wrapped up in that one little step. The where's it coming from? It's lost. All you're doing when you're converting fractions, you're adding fractions with unlike denominators. So why don't we just keep doing that? I work with students from, I work actually with teachers from India, in southern India. And C.V. Sebastian was the teacher of the year in India. And he came in, he was walking through a 5th grade class, he goes, I need to talk to you. I said, sure, Sydney, what's going on? I mean, this is a superstar teacher. And through the English, that broken English, he goes, I asked the child about his fractions, and all he did was walk me through, you multiply, then you add, and this comes over. And I said, that's correct. Why? And he said, I don't have to know why. I just have to do it. And he went, okay. He goes, why would you even teach that? And now I'm not telling you India's got the answer. But please know that India has more honor students than we have students in the United States. So just by population alone. So there's something we probably need to listen to. All right, another one through. I'm going to take the same idea and I'm going to find out. And by the way, why do you think we have more tricks on fractions than anything else? So the lowest scores in the country come from fractions. So these are all the quick tricks. So why is it that when you divide fractions, you invert and multiply? This one took a while. I'm looking at it because you got my answers. Well, I promise not to look there. Why do I do this? Why do I invert and multiply? When Paul and I were writing that book, we actually read one textbook that said, it is not for you to ask why, it is for you to invert and multiply. We're like, well, that's a little sick humor, I think. We were hoping for something a little more intellectual, thank you. Anybody know?
Is that like the identity property of one or something?
Oh my gosh. See? I mean, Jews so many years ago. All right. So in this case, it doesn't matter what fractions I choose here. Let's do 2/3 and 4/5. If you put this over as a division problem, wouldn't it be easier if I could have one fraction in the answer, not two? Well, how do I do that? Multiply the denominator fraction by its reciprocal, which means I multiply the numerator fraction by its reciprocal. What's 5/4 divided by 5/4? That's that identity principle. So what happens down here? 20/20. 1. What happened in the top? Invert and multiply. So if you just ignore that the identity property even exists in multiplication, you can invert and multiply. But what's going to happen later on? Let me show you. I certainly hope that's not me getting emails when I hear those things go off. All right. I know, Bill. We'll wait for you. All right, here we go. This is why we want to have another conversation. That's why we want to have another conversation. I was working in Detroit, and by the way, everybody puts down Detroit schools. Meet the teachers before you put down Detroit schools. Awesome teachers, right? I mean, tough situations that they're in. Awesome teachers. This is one of the algebra equations that they're trying to solve. The student is told to simplify this expression. 5 plus 1 over y, 3 plus 2y squared. Take a look what the teacher makes the students do. Look, instead of 3 and 2y squared, that's like 2 and 3/3, right? 4 and 1/2. This is simply an improper fraction waiting to happen. So what do they have to do? Multiply by its reciprocal. So in this case, we've got this piece that got this. That is the fraction that we've designed. Instead of just, well, you just multiply then add and y comes over, she makes them write the whole thing out. So if they didn't learn it in numbers, this is the first time they're ever going to see the concept. Take a look at this one. Now I have division of fractions, right? They're dividing fractions out, which means invert and multiply, numerator and denominator. And then that's why the identity principle comes out. How many people are in here, you're looking at this and wow, that is overwhelming. That's way too much stuff. Why? Is it because you're bad at math? It's because no one taught you this stuff. Because when it came to fractions, someone said, just do this. And then they got to this stuff and they said, oh, you don't have to do that, just do this. And then you get to upper level math and you go, oh my gosh, I've never seen this. What am I learning now? It's because you're relearning 4th and 5th grade all over again. And now instead of a 3, they put a y in. And suddenly the whole concept changes on it. So what does that mean to us in special education? K-12. Stick with the process. And the process is static. It should remain the same. If I had taught this in 3rd grade, if I taught this in 5th grade correctly, this is where I transition it to. Remember how I said what my tutoring is? Guess what happens when I work with a 6th grader who still can't divide fractions? I'm going to start mixing some x's and y's in there. And they'll be like, oh, I don't know how to do that yet. And I stick